Hello, my dear students. Welcome to one more amazing session for you. Today, I will teach the lecture number 3 of Basics of Maths, which is useful to you for your board preparation also. Thank you. Let's get into the session. In previous lecture, we have already discussed the analysis of two sets, equal and equivalent sets. In this lecture, we discuss subset, proper subset, power set, universal set and their properties and operations on sets, union and intersection of sets with their properties. Okay. Let's come to the session. Lecture number 3. Here, what is subset? A set A is said to be a subset of a set B if every element of set A is also an element of set B. What is meant by subset? A set A is said to be a subset of a set B if every element of set A is also an element of set B. If A is subset of B, then we denote it by A is subset of B. One example, let A equals to 1, 3, 5, 7 and B equals to 0, 1, 2, 3, 4, 5, 6, 7, 8. Then every element of set A is an element of set B. So 1 is an element of A, it is also present in set B. 3 is also present in set B. 5 is also present in set B. 7 is also present in set B. It is clear that A is clearly subset of B. Subset means every element of set A is an element of set B. One more example. If Q is set of rational numbers and R is set of real numbers, then it is clear that Q is subset of R because every rational number is also a real number. Real numbers line rational numbers also contained in real numbers. So Q is clearly subset of R. Now, proper subset. First one we discussed subset. Now proper subset. What is proper subset? Let capital A and capital B are any two sets. Those two are non-empty sets. A is called a proper subset of B if every element of A is also an element of B and there exists at least one element in B which is not present in the element, which is not an element of A. What is proper subset? Let A comma B are any two non-empty sets and A is proper subset of B. Every element of A is also an element of B and there exists at least one element in B which is not an element of A. If A is proper subset of B, then we write A is subset of B and A is not equals to B. If A is proper subset of B, then we write A is proper subset of B, A is subset of B and A is not equals to B. Second point, if A and B are two sets such that A is subset of B and B is also subset of A, then we write A equals to B. A is subset of B and B is subset of A, then we write A equals to B. Now, one more important point, every set is a subset of itself. That is, A is subset of A. Every set is a subset of itself. A is subset of A. And fourth one, null set is subset of every set. That is, phi is null set, A is any set, then it is clear that phi is always subset of every set. Phi is subset of A. These are four important note points. A is proper subset of B, then A is subset of B, but A is not equals to B. A is subset of B and B is subset of A, then we write A equals to B. Every set is subset of itself. Null set is subset of every set. That is, phi is subset of A. Now come to next point, power set. Power set. What is meant by power set? Power set means the collection of all subsets of a given set. The collection of all subsets of a set A is called the power set of A denoted by P of A. The collection of all subsets of a set A is called the power set of A, denoted by P of A. Example, if A equals to 1 comma 2, then its corresponding power set is, power set means every subset of A is called a power set. Means, for example, null set is subset of every set. One corresponding subset, set of 1, set of 2, set of 1 comma 2. If A 1 comma 2, then its corresponding power set is null set, comma, set 1, comma, set 2, comma, set 1 comma 2. So this is called, null set is subset of every set. This 1 comma 2 is called, the set itself is subset of every set. So power set of A, set of 5 comma, set of 1 comma, set of 2 comma, set of 1 comma 2. Similarly, if A equals to set of 5 comma set of 5. A equals to set of 5 comma set of 5. Then P of A equals to, this is null set, this is set of first element of the set, this is set of second element of the set, this is the set itself. So this is P of A equals to set of 5 comma set of 5 comma set of 5 comma 5 comma set of 5. Now, if n of A equals to n, then number of subsets of A, 2 power n. See here, A equals to 2 elements that A contains. Power set contains 2 square 4 elements. Similarly, A contains 2 elements, then power set contains 2 square 4 elements. If n of A equals to n, then number of subsets of A, 2 power n. Then number of subsets of A, 2 power n. Number of proper subsets of A, 2 power n minus 1. Why? Because proper subset means, what is proper subset? You cannot include the set itself. So all the sets except the given set, all the subsets except the given set is called proper subset. For example, A equals to 1 comma 2, A equals to 1 comma 2, then proper subsets of A, 5 comma set of 1 comma set of 2 only, because you cannot take the set itself, because the set itself is not proper subset. So number of proper subsets formula 2 power n minus 1. Number of proper subsets formula 2 power n minus 1. Number of subsets formula 2 power n. Next, if A equals to n, then number of elements of power set of A equals to 2 power n. Why? Because every subset is an element of its corresponding power set. Set A contains n elements. Total number of subsets 2 power n. Those 2 power n elements are the elements of its power set. So n of P of A means number of elements in power set of A is the formula 2 power n. And fourth one is important. Number of subsets of P of A. Number of subsets of P of A. So how many elements are there in P of A? 2 power n. If any set contains n elements, then number of subsets is 2 power n. So set P of A contains 2 power n elements. So its power set total number of subsets equals to 2 raised to 2 to the power of n. 2 power n. These four formulae are important. These four formulae are important. If one example, if A equals to set of 1 comma 2 comma 3, then P of A means power set, 5 means null set, set of 1, set of 2, set of 3, set of 1 2, set of 1 3, set of 2 3, and set of 1 2 3. See, n of A equals to 3, then P of A number of elements in P of A 2 power 3, 8 elements. See, 1, 2, 3, 4, 5, 6, 7, 8. N of A equals to 2 power 3. N of P of A is also 2 power 3. Number of subsets of P of A, 2 power n is the formula. So that 2 power 3. So that 2 power 8. 2 power 8 means 256. Number of subsets of power set. 2 power 8, it is 256. Now come to the point, universal set. What is meant by universal set? The universal set is the superset of all the sets under consideration. The universal set is, it is the superset of all of our sets. Universal set is superset of all our sets under consideration. And it is denoted by universal letter. First letter is U or mu. The symbol mu. This is symbol mu. So universal set denoted by U or mu. The choice of universal set is not unique. It may vary from one case to another case. Means universal set is superset of all the sets. It is not necessarily unique set. It may be many universal sets exist under our consideration. Example, if A equals to 2, 4, 6, then universal sets many exist. I wrote some universal sets of the given set A, that is U equals to set of 1, 2, 3, 4, 5, 6, 7, or U equals to 0, 2, 4, 6, 8. Because A is subset of mu. See, 2 is an element in universal set also. 4 is an element. 6 is an element. So it is clear that A is subset of mu, or A is subset of this set also. So this is universal set. This is also universal set. Similarly, we may have infinitely many universal sets exist for the given set A. Right? Next point, Venn diagram. Very important. Venn diagram. What is meant by Venn diagram? Most of the relationships between sets, can be represented by mean of diagrams. Most of the relationships between sets can be represented by mean of diagrams, which are known as Venn diagrams. These diagrams consist of rectangles and closed curves, but usually we take circles. The universal set is represented by rectangle and its subsets by circles. Means this is universal set, and some sets we may take like this. Right? We may take like this. Now, operations on sets. Operations on sets. What are operations on sets? Union of two sets, intersection of two sets, and all are called operations on sets. Their first one, union of sets. What is meant by union of sets? The union of two sets A and B is the set which consists of all those elements which are present in set A or present in set B. It is denoted by AUB, means A union B. What is union of sets? The union of two sets A and B is the set of those elements present in either set A or in set B. Mathematically, using set builder form, A union B equals to set of X such that X belongs to A or X belongs to B. A union B equals to set of X such that X belongs to A or X belongs to B. Collection of all the elements from set A or from set B together called union of two sets. For example, if A equals set of 1, 2, 3, 4 and B equals set of 2, 4, 5, 6, then A union B collect all the elements without repetitions. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, because 2, comma 4 already we have included. So that this is union of two sets. What is union? We have to collect the elements from set A or from set B. Together is called union of two sets. If any element is repeated, no need to take the element two or more number of times. In set theory, one element one time is enough. Properties of operation of union. A comma B are any two sets, then A union B is same as B union A. It is called commutative law, and A union B union C equals to A union B union C, associative law, and A union phi equals to A because phi contains no element. So A and phi total elements, the elements of set A only, and A union A equals to A because union between the sets A and A. So whatever the elements are present in A, those elements only will come into union set. A union mu equals to mu because mu contains the elements. A means every element of A is an element of mu. So A union mu is again equals to mu only. Understand what is union of two sets? The elements collection of all those elements which are present in set A and present in set B comes to union set. Now, second one, intersection of sets. The intersection of two sets A and B is the set of all those elements which are belong to both A and B. Union means A or B, but intersection means A and B. Those elements which are present in both the sets A and B only contain in intersection. Set builder form or mathematical expression A intersection B equals to set of X such that X belongs to A and X belongs to B. You have to use and here. In union, you have to use R, or R. Now, example, if A equals to 1, 2, 3, 4, B equals to 2, 3, 4, 5, then A intersection B has to take the elements present in both the sets. So 2 is present in both the sets, 3 is present in both the sets, 4 is present in both the sets. So all three elements comes to intersection of these two sets, A intersection B. So here shaded part A intersection B equals to shaded part in the diagram, Venn diagram. Here, A union B equals to again shaded part. Understand? Now, disjoint sets. What are called disjoint sets? Two sets A and B are said to be disjoint. There is no any common element between those two sets. That is, if A intersection B equals to 5, then the sets A and B are called disjoint sets. There is no any common element in the given two sets, then those sets are called disjoint sets. These definitions again we use in the chapter probability. Okay, remember all these definitions. There again I will ask. Now example for disjoint sets. A equals set of 1, 2, 3. B equals set of 4, 5, 6. Then A intersection B equals to 5. Then A and B are called disjoint sets. If you want to draw Venn diagram for disjoint sets, this is set A, this is set B. See here, no common element in set A and set B. So A intersection B equals to 5. Then those two sets are called disjoint sets. Similarly, properties of operation of intersection of two sets. A intersection B equals to B intersection A, same as union. A union B equals to B union A. Similarly, A intersection B equals to B intersection A. It is called commutative law. And A intersection B intersection C equals to A intersection B intersection C. Same as A union B union C equals to A union B union C. Associative law. A intersection phi equals to phi, because intersection means common elements only has to collect. Phi has no element, so intersection also contains phi only. A intersection mu equals to A, because A is the lesser set and mu is universal set. Common elements, obviously the elements present in set A only, so that A intersection mu is A only. A intersection A means all the elements are common in both A and A. So A intersection A is A and A union A is A. It is called idempotent law. And distributive laws. You know these laws. A intersection B union C equals to A intersection B union A intersection C. Similarly, A union B intersection C equals to A union B intersection A union C. A union B intersection C equals to A union B intersection A union C. So that's today's class. I hope all of you enjoy this class, and I hope it is clear for you. In next session, we discuss the remaining part of sets, and we discuss some previous JEE mains and advanced questions also. Okay, don't absent for next session, which is very important for you. Thank you. Thank you all.